This is your 5-minute geography lesson. We're covering Theme 3, Element 6, Physical Seismic Risks. Colouring pencils at the ready. I'm Mr. S and I'll be your 5-minute teacher. Physical seismic risks are those that are created by the hazard. This means earthquakes. There are 4 main seismic risks that we're going to be looking at today: liquefaction, tsunamis, landslides and ground movement. Let's have a look. We're going to start on the top left and we'll work our way clockwise. So the first one is also probably the most difficult to get your head round, and that is liquefaction. As a risk, it's actually quite rare. We don't have a lot of photographic or video evidence of this occurring. There's some brilliant YouTube clips that you can research if you type in liquefaction Japan, and you can actually see liquefaction in action. But essentially, liquefaction is the land acting like a liquid. So as the earth shakes, it vibrates all of the little particles, particularly in sedimentary rock, and this tends to happen closer to the coastlines where this rock is built up and these sediments are built up. Sedimentary doesn't tend to be very well pacted together, so it's not really that as rigid as some other types of rock. And this means that it allows, when that seismic energy comes through the rock, to vibrate the different elements, and that encourages it to move as a liquid. But an important factor that also occurs near the coast, the groundwater table, so where the water is stored in the ground, is actually quite close to the surface. And as this vibration occurs and these particles are moving, it forces the water from the ground table to rise up to the surface. And we can see evidence of that here, where we've got these big puddles on the ground. That's water that's been forced up through the ground by the vibration of the rock. The impact of this then, as you can see, we've got some cars that have actually sunk into the soil and the ground as it shook. But it's not just cars that are going to be affected by this. This can affect housing as well. There's evidence where entire buildings have had their foundations compromised. So these huge blocks of concrete designed to anchor and keep a building in place. Because the ground's moving and acting like a liquid, one side of the foundation is sunk, the other side has been pushed out of the ground, and you've got a building that's sat at a jaunty angle, which means that you can't live in there anymore, and the only thing to do would be to knock it down. The second one we've got are landslides. These are more common and something we probably associate quite regularly with earthquakes. As this intense ground shaking occurs, the rock, and again this is particularly on sedimentary layers, because they do build up in layers, they've got things called bedding planes and joints. So bedding planes are horizontal lines between different layers, and they're weaknesses in the rock. As the earthquake's seismic energy rolls through the rock, it influences that weakness, and in some cases, like we can see here, the entire side of a cliff or section of that rock is going to slide away down. And it's slid on that bedding plane, because that's the weakness. It can also be chunks, so you can see here there's a chunk that's been left behind, but equally it could have been there was a chunk that came off as a rock fall. Next we have ground movement, and this is the core effect of any earthquake. It's the shaking of the ground. So when earthquakes occur, it's a massive release of energy that's stored up friction as these two plates try to move past each other. This is called a seismic wave. And as that wave moves through the ground, it's moving either up and down or side to side. And that's what produces our shaking. And the impact occurs across the local environment, can destroy buildings, infrastructure, gas and pipe works. There is a whole host of things and knock-on effects that this can influence. And this leads us to our last one, and arguably one of the most deadly or potentially dangerous risks, and that are tsunamis. And it sounds like this should be its own part of the syllabus. A tsunami is a very deadly natural hazard. However, it's also a secondary impact or a secondary effect of an earthquake. So tsunamis happen when earthquakes occur underwater. The seismic wave forces a column of water up as a giant wave, and these produce fast traveling with an extreme energy and colossal waves that can devastate entire coastlands locally, nationally and even globally, as was the case in the 2004 Boxing Day tsunami. These are omnidirectional waves. That means that they move out in all directions, not just one, so they can cover vast areas of coastlines when they reach it. Well, that's it for today. But continue your own revision by trying the now tried tasks for homework. Class dismissed.